Hello everyone. Today we are going to discuss the polynomial part 2. In this part 2 video, we are discussing the graphical representation of a polynomial. So here in this video, the first one is how to draw the graph of a linear polynomial. So a linear polynomial, how to draw the graph of a linear polynomial. So I'll take a small example here. Y is equal to 2x plus 3, which is a linear polynomial. So for this linear polynomial, how to draw the graph? So before going to draw the graph, first of all, we have to draw the tabular form for this one. So in the tabular form, we have to keep the x values, we have to substitute the x values, and we should get the y values. So for that, I'm taking the tabular form. So in this tabular form, so here this x is my independent variable, variable. It's not depend on any value, it will take its own value. Y is dependent value on x, dependent on x. So first I'll put the x is 0. So I'll get y is equal to 2 into 0 plus 3, which is 3. And next I will put y is equal to 0. So why I'm doing like this means, by putting 0 once in x plus, by putting 0 in once y plus, almost I'll get the graph of a linear polynomial. Remaining all values are not required. But for your purpose, some students will get the doubt how to take the different values. I'll put the remaining values also. So when I'll put the y value is 0, it will become 0 is equal to 2x plus 3. Very clearly, x value is minus 3 by 2, which is nothing but minus 1.5. So when I'll take the y value as 0, x value I got minus 1.5. So I'll put the x is equal to 1. So I'll get y is equal to 2 into 1 plus 3, which is 5. So if I'll take x is equal to minus 1, y will be 2 into minus 1 plus 3, which is 1. So you can take 2 minus 2, 3 minus 3, like that many values, but it's not required. So by using this 0, 3 and minus 1, 5 only, maximum we can finish up the graph of a linear polynomial. So 0, 3 minus 1.5, 0. So extra I'll take minus 1, 5 and minus 1, 1 also. So let's see the graph of this linear polynomial. So I'm taking a coordinate system. So this is my y-axis and this is my x-axis. So x, O, x dash, y, O, y dash. So here on x-axis I need 1, 2, 3, enough, minus 1, minus 2, minus 3, minus 4. So here I need 1, 2, 3, and the next 4 here somewhere, like that. So if you look at the points which we have to plot on the graph, so first is 0, 3. So x coordinate is 0 means the point lies on the y-axis. So here is a 0, 3, my first point. Next, minus 1.5, 0. Y coordinate is 0 and the x value is negative. So it lies on negative x-axis, which is minus 1.5, 0. And we have one more value, minus 1, 1 here. So it will be like this, 1, 5 somewhere, it will be like this. So join these all points. So you'll get a straight line like this. So it's a straight line, which is the graph of y is equal to 2x plus 3. So what we understood from this graph is graph of a linear polynomial. Therefore, graph of a linear polynomial, is a straight line. So this is the graphical representation of a linear polynomial. So let's see graphical representation of a quadratic polynomial. Graphical representation, graphical representation of a quadratic polynomial. So graphical representation of a quadratic polynomial. So how to represent, how to draw the graph of a quadratic polynomial. So the well-known example I'm taking here, y is equal to x square minus 5x plus 6, whose zeros are, x values are nothing but 2 comma 3. So this 2 comma 3 satisfies the that particular x square minus 5x plus 6 quadratic polynomial. So by graph also we have to show same thing. So how to draw the graph? I told you already. First of all, we have to go with the tabular form. So tabular form is here. So different values I'll take. I'll take the different values for x. By that I'll get the different values for y. First I'll take the 0. So y is equal to 0 square minus 5 into 0 plus 6, which is 6. So I'll get the 6. I'll take the 6. So next I'll substitute x is equal to 1. So y will be 1 square minus 5 into 1 plus 6. So it will be 2. I'll substitute the 2. X is equal to 2, I'll substitute. Y is equal to 2 square minus 5 into 2 plus 6, which is 4 minus 10 plus 6, which is 0. I'll substitute 3. I'll substitute 3. I'll substitute 3. So y is equal to 3 square minus 5 into 3 plus 6, which is 9 minus 15 plus 6, which is 0. So when I'll substitute the 3, I'll get 0. Next, I'll substitute x is equal to 4. I'll substitute x is equal to 4. Y is equal to 4 square minus 5 into 4 plus 6, which is 16 minus 20 plus 6, means 2. So next, when I'll substitute 5, y is equal to 5 square minus 5 into 5 plus 6, which is 25 minus 25 plus 6, which is 6. So depending on the graph, for the perfect graph, let's see if any values are required. So till now, what we took is the order pairs 0, 6, 1, 2, 2, 0, 3, 0, 4, 2, 5, 6. So these are the values we took here. So let's see go with the graph. So let's we consider this is our y-axis and this is x-axis. Better we will take this x-axis little down.